Hi, everyone. 12.3, there's two things you need to know. And actually, for the second, I'm just going to make sure you can use the calculator to do it. So, number one, determine the range for a data set. And number two, determine the standard deviation for a data set. Okay, so the range, hopefully you remember, or at least kind of it seems familiar to you, that to find the range, you simply take the maximum number and you subtract the minimum number. What this kind of problem is talking about is that Hawaii and Houston have the same mean temperature of 75 degrees, but that they're really different. Like Houston will get cold in the winter and hot in the summer, and then it averages out to 75 degrees. Whereas in Honolulu, it's pretty close to 75 degrees the entire year. So even though there's a bigger range in Houston than there is in Honolulu, they average out to be the same number. So down here, we have the formula. Okay, you probably don't need it, but in case you forget, this is on page 800. All right, and so for the example, figure 12.8, the age of the oldest US presidents at the start of their first term, find the age range for the oldest presidents. So at this point, Trump, it is election day as I am making this. Trump is the oldest elected president. If Joe Biden wins today, it will be him instead. At 70 years old, it was Trump. And this says, and then we're subtracting out the age minus. So we're only talking about the four oldest US presidents. I was like, wait a minute, that seems wrong. So you take 70 minus 65, which is the youngest of these four presidents, not of all the presidents, and you get a range of 5 years. Okay, so you took the largest number, 70, subtracted the smallest number, 65, and our range was 5 years. So if we want to find the range of the following group of data, what we are going to do is take the largest number, which is 11, and subtract out the smallest number, 2. And our, whoops, my brain was doing the math. Subtract out 2, and our range is 9. Okay. And the second part is we're talking about the standard deviation. So I'm not going to make you do it the long way by hand, but I am going to go over what the standard deviation means. The standard deviation is, I always like to say, it's the average distance from each piece of data to the mean. Okay, and the way that I usually explain this is if we had, let me go down to a blank piece of paper here real quick so I can go through this. So the way I like to explain it is like, so here is our, if we look at our school, DCIS, and then this is kind of 6th Avenue here. And if I'm looking at the front of DCIS, we have the mountains over here. Okay, these are supposed to be mountains. But anyway, this is west, right? And over here we have the city. There's the cash register building. And so this is east. Okay. And let's pretend that all of the students either live west or east of our school at different places, right? Student lives here, student lives here, student lives here, 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 here. So let's say this student lives 2 miles away, and let's say this student lives 8 miles away. And then let's say this student lives 6 miles away, but in the opposite direction. It doesn't matter. This is 6 miles west, this is 8 miles east. The standard deviation would be taking all of those distances and figuring out how far away they are from DCIS. So this person is 6 miles west of DCIS. This person is 2 miles east of DCIS. So figuring out how far the deviation, that's called the deviation. So how far away is the deviation? Okay. And then what we do is we find the average of those deviations, and that is the standard deviation. Deviation. I hope I'm spelling that right. Okay, so the deviation is how far away each student lives. The standard deviation is the average of all of those numbers. Okay, so that's what we're talking about. The book goes into how to find that by hand. Like I said, I don't expect you to memorize how to do that, but I am going to go through it. So the first thing you do is you find the mean. The mean is, in my metaphor, the mean would be the school. Okay, the mean would be the school. And then deviation from the mean would be the piece of data. Okay, and here we're using those president's ages minus the mean. Okay, so 70 away from 68 is 2. 65 away from 68 is 3. They made it negative only to tell you that the 65 is smaller than the mean. And up here, this is a positive 2 because 70 is larger than the mean. So they find each of that from the pieces of data. Those are the deviations. Okay, so what they do is they find the mean, then they find each deviation. Then in order to get rid of those negative deviations, they square each number. Because remember, every time you square a number, if it's negative or positive, you're going to get a positive. Then they find the average. They add those up. They divide it by how many they are. And then at the end, they have to take the square root of that because remember, they had squared the data in the first place. When they take the average to get rid of some bias, okay, they actually divide by n minus 1. There are ways to do it, and this is based in statistics. There are ways to do it where you just divide by the number, but then you have a little bit more bias. So your calculator will actually give you both answers. All right, so that's how you do it. Feel free to walk through this and do it the long way. I had a couple of students last year do it the long way. Let's go back really quickly because checkpoint 2 was asking you to find the deviation of each of these numbers. So the first step was to find the mean. So we take 2 plus 4 plus 7 plus 11, which is going to be 24, and divide it by 4. So our mean is 6. And then to find the deviation of each number, you would say, okay, the first number is 2. So 2 minus 6 is going to be negative 4. So the deviation is that 2 is smaller than 6 by 4. Then we have 4 minus 6, and that deviation is negative 2. Then I'm going to erase this so you guys don't think it's a fraction. Then we have 7 minus 6, that deviation is positive 1, and 11 minus 6, that deviation is positive 5. Okay, so those are the deviations. All right, so part 3, if you want to know how to do it by hand, please walk through this example. And then I'm going to show you how to use your calculator to do it. So checkpoint 3 is asking us to find the standard deviation for the group of data that we just did. So those numbers were 2, 4, 7, and 11. So using your calculator, the first thing we're going to do is hit stat enter so that we can put these numbers into a list. Let me delete this so we can start fresh. So I'm going to use list 1. So again, I hit stat, enter. I'm going to list 1. I'm going to enter in this data. It doesn't matter what order you put them in. So I'm just going to do them in order 2, 4. I'm hitting enter each time. 7 and 11. Then we're going to go back to the stat button. We're going to go over to calc and we're going to hit 1var stats. And we're hitting 1var stats because we only put numbers in one list. If we were dealing with two different variables, so we put numbers in list 1 and list 2 to see if they're correlated, we would have used 2var stats, but we are only using one variable statistics. That's what var stands for, variable. Now I need to put in what list I used. So I'm going to do second 1 because I used list 1. Remember, I had to remember what that was. And then I'm going to hit enter. And let me just tell you what these mean. So the X bar is 6X bar up here. The very first one is the mean. Okay. The sigma of X, 24, that means the sum when we added up all of the numbers. Sigma X squared is the sum of all of the numbers squared. Okay, if I squared the numbers and then I added them up. And then this is the standard deviation that you are looking at. S of X right here, 3.9. That's the one we do in the book. Remember, I told you that sometimes you just divide by the number, not the number minus 1. And that's our little sigma of X here, 3.4. So both of these are standard deviations. The one the book's using is the S of X, not the sigma X here. Okay, n equals 4. That is the number of numbers. Okay, that's the count of the numbers, how many we had. Then it gives us a couple other things. It gives us the minimum number, quartile 1, the median, quartile 3, and the maximum. So it gives you the 5-number summary also. But we were only really interested in the standard deviation. It was that first one, S of X, SX. All right, so in this case, approximately 3.9. That means each of these, the average of the distances from these numbers to 6 is 3.9. All right, so example 4, it looks like it's doing it again by hand. And it is using these two sample A and sample B numbers. So let's practice. I can practice this again with you, putting them into the calculator. Good morning, Arnold. So if we do, let's do sample B because I can see it at the same time I have my calculator open. So I'm going to do stat, enter, and then you guys can do example A on your own. So I'm going to enter in here the numbers from the table, 5, 10, 15. I was just counting by 5s. 20, 25, 30, 35. Okay. Stat, calc, 1var stats. Enter. And our standard deviation is approximately 10.8. And you see that right here. Okay, so you guys practice your calculator with sample A. Example 5. Oh, it wants us to interpret the standard deviation. So here it looks like we're talking about, here's checkpoint 4. Finding the standard deviation, entering those numbers into the calculator. So we hit stat and then enter. That arrow means enter, then stat, and then right arrow to calc. then 1 var stats. And then, like I said, I used list 1. All right. 2 fifth grade classes have nearly identical mean scores on an aptitude test, but we want to find the range. So what that standard deviation gives us is the range of numbers. So one class has a standard deviation of 3 times. So a bigger standard deviation means the numbers are farther away from the mean. All other factors being equal, which class is easier to teach and why? So that's an interesting question as a teacher. Before I read through this, I'm going to say the one with the smaller standard deviation because kids are mostly in the same spot. If students have a larger standard deviation, that means some kids are really low, some kids are really high. That makes it a little bit harder to teach when students aren't in the same spot. The class with the smaller standard deviation is easier to teach. Cool, that's what I just said. There's less variation. I said range. Coursework can be aimed at the average student without too much concern that their work will be too easy or too difficult, right? By contrast, the class with greater dispersion poses a greater challenge. By teaching to the average student, the student whose scores are significantly above the mean will be bored. Students whose scores are significantly below the mean will be confused, okay? So checkpoint 5. The mean standard deviations yearly and standard deviations of the yearly returns on 2 investments. Use the means to determine which investment provided the greater yearly return. Okay, so a bigger mean means that they had a larger number that skewed it bigger. So that's going to be the small company. Use the standard deviations to determine which investment had a greater risk. Well, that's going to be the same one, greater risk, greater reward. The standard deviation of 33.3% means even though they had some people way up here at the top, they also had some people farther down on the other side. All right, that's it for 12.3.